This is SpaceTime Series 22, Episode 24. Coming up on SpaceTime, another 83 supermassive black holes discovered in the early universe. A new gravity experiment shows that Albert Einstein's still right. And the world's biggest telescope moves a step closer to fruition. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered 83 monstrous black holes feeding in the early universe. The findings, reported in the astrophysical journal Letters and on the pre-press physics website archive.org, dramatically increases the number of supermassive black holes known from this ancient epoch. And it reveals for the first time just how common these giant gravity wells really were in the early universe. Supermassive black holes are found at the centers of galaxies and have masses millions to billions of times that of the Sun. While they're prevalent across the modern universe, it's still unclear to astronomers exactly when they first began forming or how many could have existed in the early universe. Nor is it understood how supermassive black holes could have gotten so massive so early in cosmic history. Astronomers can't observe supermassive black holes directly, but they can observe their presence when large quantities of matter falls into a black hole. As matter falls into a black hole and lands on the accretion disk, it's crushed, twisted and ripped apart at the subatomic level, in the process releasing huge amounts of energy before finally moving beyond the black hole's event horizon and disappearing forever into the singularity. But all this energy released from matter before it disappears into a black hole is so bright it shines like a beacon across the universe, forming an object we call a quasar. The authors, led by Yoshiki Matsuoka from Ehime University, made their discoveries using the Subaru telescope specifically to look for populations of quasars in the distant universe. The most distant quasar detected by the team was some 13.05 billion light-years away, meaning it's tied for second place as the most distant quasar ever observed. The light's now providing us with an image of what things looked like 13 billion years ago, a time when the universe was just 5% of its current age. The survey revealed 83 previously unknown distant quasars, together with a further 17 quasars which had already been identified in an earlier survey. Previous studies had only been sensitive enough to detect the most luminous quasars, and thus the most massive black holes. But these new discoveries are probing a population of supermassive black holes with masses more characteristic of the most common quasars seen in the modern universe, thereby shedding more light on their mysterious origins. Interestingly, the survey also found that the average spacing between supermassive black holes is around 1 billion light-years. Matsuoka says the quasars his team have discovered will provide interesting subjects for further follow-up observations, both with current and future facilities. This will allow astronomers to learn more about the formation and early evolution of supermassive black holes by comparing the measured number density and luminosity distribution with predictions from theoretical models. You're listening to SpaceTime. I'm Stuart Gary. March 14th was celebrated around the world as International Pi Day, the date in American speak being the same as Pi 3.14. But it also marked the birthday of one of the greatest scientists that ever lived, Professor Albert Einstein, the father of relativity theory. Einstein's general theory of relativity, published in 1916, was an extension of his earlier 1905 work on special relativity theory, which did not include gravity but dealt only with inertial motion, that is, motion with constant velocity. General relativity added the effects of the gravitational force. To date, scientists have performed countless tests of general relativity theory, all in the hope of finding violations of the theory which could lead to solving important puzzles in physics and science, like dark matter and dark energy. But so far, none have been successful in violating Dr. Einstein's work. The thing is, these tests have so far been limited to relatively weak gravitational fields, such as those produced by the Sun or by white dwarf stars, which have similar masses and consequently similar gravitational wells to the Sun. But now, scientists with the Gravity Collaboration have performed general relativity experiments using the strongest gravitational field ever used for such tests, the supermassive black hole at the centre of the Milky Way galaxy. This black hole, known as Sagittarius A star, is located some 26,000 light-years from Earth and contains as much mass as 4.2 million suns. The research team tested general relativity's equivalence principle. In its simplest terms, the equivalence principle states that the inertial force and the gravitational force are the same thing, and so acceleration and gravity are also the same thing. It means a freely falling observer in a gravitational field doesn't feel gravity. In other words, the observer is weightless. In a small region of space around an observer in free fall in a gravitational field, the laws of physics are approximately the same as without gravitation, at least for a time-limited observational period. A more restricted version, called the weak equivalence principle, demonstrates that in a gravitational field, objects which are at the same location are also subjected to the same gravitational acceleration, and so fall at the same rate. The test used by the Gravity Collaboration involved observing the light emitted from two atoms, one hydrogen, the other helium, within a star orbiting Sagittarius A star. Because of gravitational redshift, the light's apparent frequency changes as the star reaches its closest approach to the black hole. The author's observations, reported in the journal Physical Review Letters and on the pre-press physics website archive.org, were in total agreement with the predictions of general relativity, with the changes for the different atoms being the same. It's all more proof that it's never a good idea to bet against Professor Einstein. But the authors suggest that next-generation telescopes, such as the extremely large telescope now being built, should be able to carry out the same test with 10,000 times better accuracy than our current state-of-the-art facilities. I'm Stuart Gary. You're listening to SpaceTime. Development of the world's largest telescope, the Square Kilometre Array, has moved a step closer to fruition with the formal signing of an international treaty establishing the intergovernmental organisation that will oversee the delivery of the project. Ambassadors, ministers and other high-ranking officials from the 7 founding nations, Australia, the United Kingdom, South Africa, China, Italy, the Netherlands and Portugal, were in Rome for the formal ceremony, which will ultimately culminate in the delivery and operation of the Square Kilometre Array Observatory. India, Sweden, Canada, France, Malta, New Zealand, South Korea, Spain and Switzerland were also present for the signing ceremony, expressing their interest in joining the project at some later stage. Once built, the Square Kilometre Array will eclipse CERN as the largest scientific facility on the planet. Headquartered at the Jodrell Bank Observatory near Manchester, the project will use 2 networks of hundreds of dishes and thousands of antennas distributed across hundreds of kilometres of the Australian outback and the South African Karoo. Its size and wide range of operating frequencies will make the Square Kilometre Array at least 50 times more sensitive than any other radio instrument on Earth. The observatory will include the SKA low-frequency phased arrays of dipole antennas covering the 50 to 350 MHz frequency range and grouped in 100-metre diameter stations, each containing about 90 elements. Then there's the SKA mid-frequency array, which will include several thousand 12-metre dish antennas to cover the 350 MHz to 14 GHz frequency range. Finally, there's the SKA survey array. It'll use a compact array of 12 to 15 metre diameter parabolic medium frequency dishes, each equipped with a multi-beam phased array feed with a large field of view covering the 350 MHz to 4 GHz frequency range. 2 of the world's biggest and fastest supercomputers will be needed to process the unprecedented amounts of data expected to be produced by the observatory. In fact, some 600 petabytes of data is expected to be stored and distributed worldwide to the science community every year. And that's enough to fill more than 500,000 high-end laptops. The Australian Square Kilometre Array facility will be based at the CSIRO's Murchison Radio Astronomy Observatory in Western Australia. The observatory already has 2 operational main instruments. There's the Australian Square Kilometre Array Pathfinder, or ASCAP. It uses 36 identical 12-metre diameter dishes working together as a single instrument to provide a very fast survey speed with extremely high sensitivity. And then there's the Murchison wide-field array of 80 to 300 MHz low-frequency, fully cross-correlating single dipoles on 128 phase tiles, each comprising 16 dipoles. A third separate instrument at the observatory is the experiment to detect the global EOR signature or edges antenna and low noise amplifier radio telescope. It's designed to detect the redshifted 21 centimetre hydrogen line from the cosmic dawn and epoch of reionization, which corresponds to a redshift of 27. On the other side of the Indian Ocean and the South African precursor facility is the Meerkat array of 64 13.5 metre dishes covering the 580 MHz to 14 GHz frequency range. There are also a further 7 dishes known as CAT-7, which are used as an engineering and science testbed facility. The Director General of the Square Kilometre Array organisation, Professor Philip Diamond, who led the design of the telescope, says like Galileo's telescope of its day, the SKA will revolutionise how science understands the world around us and our place in it. More than 1,000 engineers and scientists have been involved simply in designing the SKA over the past 5 years. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Let's talk about this international treaty, the Square Kilometre Array. They've signed, sealed, and, well, I'm guessing they're going to deliver.
Indeed, that's right. So this goes to, the story is about an event that took place in Rome, in fact, in which a number of dignitaries from the countries that are involved, and that includes Australia, signed something called the SKA Observatory Convention. It's a treaty, basically, an international treaty, which is of very great international stature. So SKA stands for Square Kilometre Array. It is the name of what will be the biggest radio telescope in the world when it's finished in probably the late 2020s. It's called SKA and Square Kilometre Array because it will have a radio collecting area of 1 million square metres, which is a square kilometre.
And for the Americans who are listening that don't understand the metric system, that's about 5 yards.
I think that's wrong. 1 million square. Yes, it's. I should be able to tell you what it is in acres, but I'm not going to do that. It's a lot, very large number of acres. So a square kilometre array, it's something that has been worked on for the better part of a decade, in fact longer, because both the main countries which will host the telescope, that's Australia and South Africa, although there are other countries involved, those two countries have both now got operating Pathfinder versions of the SKA. In Australia, it's called ASCAP, which is the Australian Square Kilometre Array Pathfinder. In South Africa, it's called Meerkat, which is a much more elegant name.
Oh, I like that. Actually, we've got meerkats in Dubbo at our zoo.
The zoo, that's right.
They are so cute.
Yeah, what's really cute about this name, Andrew, is the way it was derived, because meerkat is partly an acronym. So there was something called CAT, which was the Karoo Array Telescope, and that the SKA, of course, is an array. The South African version is in the Karoo, which is a high region, plateau region of South Africa. So CAT was the Karoo Array Telescope, but then the South African government said, well, we can give you more funding to increase the number. I think it was going to be about 30 dishes. And they increased it to, I think, 64, if I remember rightly, which was great. So they decided to call it Moorkat, but in Afrikaans, Moor is meer, so it became Meerkat.
And I can tell you that a square kilometre is a mere 247 acres.
There you go. Thank you. So this is it should be called the 247-acre telescope, but it's called the Square Kilometre Array. Okay, so the instrument itself will be spread between southern Africa, because it involves more than just South Africa, and Australia and New Zealand, because the nucleus of it is in Western Australia, but the antennas will spread outwards, and the most remote ones will be on New Zealand soil. So it is a project that is really going to set astronomy on fire in the next, well, they hope it'll last for 50 years, this project. Our bit here in Australia is very much concerned with the low frequency end of the radio spectrum. So where the South African Square Kilometre Array components will have steerable dishes, here in Australia we've got sort of fields of things that look like Christmas trees. They're antennas that just sit there, and they're actually steered electronically. It's amazing science. You don't have to point it anywhere. You just have all these rows of antennas, and there are going to be 130,000 of them altogether.
Good grief, really?
Yeah, and you basically actually steer the beam around so you can see. In fact, you can look at the whole sky at once, is my understanding of it, but you've certainly got to select the objects of interest. So the telescope in Australia is being built actually on land belonging to the Wajiri Yamadi people. They are the traditional owners of the land, and they've had a great relationship with the Square Kilometre Array personnel. I did mispronounce that, actually, because there's when you see it written, what you pronounce is slightly different. It is Wajiri Yamaji. That's the correct pronunciation.
Some of the Aboriginal terminology is very hard to get your head around. We have some amazing street names in my hometown here in Dubbo, and when people ring up and say, "And you're in Wingawara," it's Winjawara.
Winjawara, that's right. I know Winjawara Street well. As I said, the Square Kilometre Array and the Indigenous people have had a great relationship in essentially dedicating this land, which has a very low population level, to the project. Of course, it's that population density, the very low population density, that makes Western Australia such an attractive site for a radio telescope, because there's no mobile phones, no microwave cookers, nothing that actually leaks out radiation.
Yeah, not even in Perth, they're so backward. But
I'm not going to go there.
It does bring up the point that Perth, the capital of Western Australia, which is an absolutely beautiful city, I have some good friends there, is the most isolated city in the world.
That's right. And this is 800 kilometres further away from Perth. So it is very, very isolated. The radio quietness there is exquisite. That's been demonstrated a number of times by the Pathfinder and a number of other radio telescopes that have been built on this site, which, by the way, is called the Murchison Radio Astronomy Observatory. So what was this treaty signing all about? This was what committed the various countries, and it's an increasing number of countries that are joining in this project. Probably be something like 21 when everybody signed up. The signing in Rome, which involved actually our ambassador, the Australian ambassador in Rome, he was the person who signed the deal. It's a bit like the start of something like the European Nuclear Research Centre, which we know as CERN. And you and I talk about CERN a lot because they've got a Large Hadron Collider, which is one of the biggest pieces of scientific infrastructure in the world. The thing about this is it's the same kind of deal, and we are hosting something of the same significance, if not more so, than the Large Hadron Collider on Australian soil. It will be the largest scientific instrument ever built when it's finished. It's what you might call mega science project. And so this signing really is a big deal for Australia.
Yeah. Nuts and bolts, though, what are they looking for?
Good question. So I was hoping you'd ask me that, because that's what I was about to tell you next. Just shows how well synced we are.
Oh, indeed. It only took 20 years.
Yeah, it did. 20 agonizing years. Okay, questions really are very fundamental ones. It kind of starts with the Dark Ages. You remember yourself after the Big Bang, for the first, we don't know how many million years, but for the first period of time, there were no stars shining in the universe. The Big Bang itself occurred. It was a big flash, which lasted for about 380,000 years. It was a long flash. But sometime after that, the universe became dark, and it was then probably length of time measured in of order of 100 million years before the first stars switched on. So there's this dark period immediately after the Big Bang that we can't probe with normal visible light telescopes because there weren't any stars. So you've got to look at it in radio waves, because cold hydrogen, which is what was around at that time, actually emits radio radiation, and we can detect that. So that's, the first thing, investigate the Dark Ages. Then things like, how did magnetism originate in the universe? We don't know the answer to that. Questions about gravitational waves, this kind of thing will also fit into that. We've talked about gravitational waves before. These are caused by dramatic events in the universe. The Square Kilometre Array will have the wherewithal to pick up these events in the radio spectrum as well. Something we have talked about several times, fast radio bursts, or as they are correctly known, fast radio bursts. Yes. They are one of the big mysteries of modern astronomy. And the Square Kilometre Array is ideally suited to studying them. These are things that shine very brightly in the radio spectrum for something like 3 or 4 milliseconds and then disappear. And apart from a handful of repeating ones, they're never seen again. So what are they? Are they something at the end of its life that's blowing up in a cataclysm? We just don't know the answer to that. That's one of the things. themes that will be addressed by the SKA and indeed is already being addressed by the Pathfinders. And finally, the ultimate question, are we alone? Because the SKA will have the sensitivity enough to pick up an airport radar. I love this statistic. Pick up an airport radar at 50 light years.
Wow.
So,
when will it be operational, do you think?
they're kind of already in the sense of the Square Kilometre Array Pathfinder being operating, it will probably come on stream in various stages. One of the really interesting things is the amount of computing power you need, because that computing power doesn't exist at the moment. But it will do by the time they get there. So the estimate...
They might have to make a quantum leap.
Well, quantum leap is always good, especially if you can involve quantum physics.
Yes.
CSIRO, of course, they run the Murchison Radio Astronomy Observatory. They will host the Square Kilometre Array telescope at Murchison. And the other thing I was going to mention is, and this goes back to your question, it's expected that something like $1 billion worth of construction contracts will start to be awarded for the SKA, and that will be from late next year, late 2020. We'll start seeing throughout the world invitations to contract on the manufacture of various parts of it. So it's fantastic stuff.
It is.
And really a good news story.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims more than 1 in 5 future pancreatic cancers could be traced back to smoking, and most could be prevented if current smokers were to quit. The findings, reported in the Medical Journal of Australia, looked at the cancer and death registries to obtain data on more than 300,000 people. They found that current and recent smoking explains some 22% of all future pancreatic cancer burden, with the figure being much higher for men. A new study by Danish researchers has concluded that low-dose aspirin doesn't appear to reduce the overall risk of death from prostate cancer. The research followed other studies which had suggested that aspirin could be used to improve survival in patients with prostate cancer, but those study results were considered inconclusive. The new study did find that men who had a type of prostate cancer that was unlikely to progress were at a slightly lower risk of dying than their peers who did not pop the aspirin pills. However, an attached editorial in the journal of the study, Annals of Internal Medicine, suggested this lowered risk could simply be explained by inaccurate tumour grading. A new study concludes that the world's oceans absorbed nearly a third of human-caused carbon dioxide emissions between 1994 and 2007. But it also found that this has come at an extreme cost to our seas and the life within it. The ocean's role as a so-called carbon sink means carbon dioxide doesn't accumulate in the atmosphere quite as quickly as it otherwise would, providing a buffer against rising global temperatures and climate change. Now, a report in the journal Science has found that this rate of carbon storage has stayed stable since before the industrial era, but that all that carbon has dramatically increased ocean acidification, which is now reaching down to the ocean's deepest depths. New research, reported in the Proceedings of the National Academy of Sciences, has cast doubt on what ultimately caused the collapse of the once great city-state of Angkor in what is now Cambodia. The new research, by scientists with the University of Sydney, has revealed that the ancient city of Angkor underwent a slow, gradual decline, rather than a sudden, abrupt, catastrophic collapse. Archaeologists have long debated the likely causes for the demise of the ancient capital of the Khmer Empire, which flourished between the 9th and 15th centuries. The ruins of Angkor are located amid forests and farmland north of the Great Lake and include over 1,000 temples, ranging in size from nondescript piles of brick rubble scattered through rice fields to the world's largest single religious monument, the Great Angkor Wat. Satellite images and ground observations have concluded that Angkor was the largest pre-industrial city in the world, with an elaborate infrastructure system connecting an urban sprawl of at least 1,000 kilometres. The end of the Angkorian period is generally set at around 1431, the year Angkor was sacked and looted by Ayutthaya invaders. But the civilization had already been in decline since the 13th and 14th centuries. During the course of the 15th century, nearly all of Angkor was abandoned, except that is for Angkor Wat, which remained a Buddhist shrine. Scientists have developed a glass surface that never gets dirty and never needs cleaning. A report in the journal Nanoletters claims the secret to a scrub-free shine are microscopic pancakes. Previous self-cleaning surfaces use tiny micropillar structures with a coating material that repels oil and dirt. The narrow pillar tops also give grime less area to stick. The problem is these tall, thin columns easily bend and snap, allowing dirt and oil to collect around the damaged pillars. So instead of pillars, scientists are now experimenting with shorter, squatter pancake shapes. Researchers say the new design doesn't break as easily, and it allows water to flow more easily around the shorter structures, preventing dirt from sticking. A new study claims that humans may be able to sense the Earth's magnetic field. In a discovery that feels, well, let's face it, a bit like X-Men meets real life, a report in the journal eNeuro claims humans may possess an ability called magnetoreception, that is, the ability to, at least unconsciously, perceive the Earth's magnetic field. Scientists reached their conclusions after recording adult brain activity using EEGs while the subjects sat in a special chamber designed to simulate the magnetic field of the Northern Hemisphere. The researchers then detected changes in alpha brainwave activity, which indicated a response to changes in the magnetic field. Normally sane, calm people, it seems, are willing to believe in all sorts of crazy things, from haunted houses to psychic chihuahuas. And to that end, the New South Wales Southern Highlands town of Picton, about 100 kilometres south of Sydney, has been named as Australia's most haunted town, while Victoria's Ararat Lunatic Asylum and the Monte Cristo Homestead in country New South Wales have also been given honourable mentions. With this somewhat light-hearted look at the crazy things people believe in, we're joined by Tim Mendham from Australian Skeptics.
Every time we have a newsletter that comes every fortnight, we always like to give some travel tips to people. And most of these revolve around haunted locations you can go to. And basically, these are lists supplied by a whole range of different people. And we like to sort of provide them and then put some commentary. The most haunted locations in Australian list is rather disappointing. Most of these lists are the top 10. With Australia as the top 3. Surely you can do better than that.
Ghosts don't like Australia.
Well, I don't know. I mean, I'm sure there are a lot of other places. I mean, the number one place was a lunatic asylum, in quotes, and not the correct terminology, but in Ararat in Victoria. There was a Monte Cristo homestead in country New South Wales, which was said to be the most haunted private residence in Australian history, according to the Monte Cristo homestead. And, of course, there's a place near Picton, near Sydney, actually, which is dubbed the most haunted town in Australia.
Well, that's Fisher's Ghost, is it? That's the Fisher's Ghost?
No, Fisher's Ghost is Campbelltown.
That's a Campbell. That's nearby for people
it's
that
sort
don't
of
know.
nearby-ish.
Yeah,
but Fisher's Ghost is one little bridge.
Yes,
it's one little bridge, and it sort of appears. Picton I've never heard has been the most haunted town in Australia, but apparently they say it is, so it is. At the same time, of course, as the haunted places in Australia, you'd also look at haunted hotels around the world. There's a new list of the top 10 haunted hotels in the world, whether it's a pub in England or whatever. What comes up every time when they do a global list is this place called the Stanley Hotel in Colorado. And the Stanley Hotel in Colorado was the place where Stephen King set The Shining, the book about,
Except on The Simpsons, where it's called The Shinning.
Yes. The trouble is, the Stanley Hotel is always quoted as a thing, but no one really knows it because it was in the book. But it's not in the film. The one in the film is a totally different hotel. So therefore, people picture the one in The Shining, but that's not the one which is haunted. And I'm sure the Stanley Hotel loves it, the fact that they're in every top 10 lists of haunted places and haunted hotels, and that they make a lot of money out of it.
What's this I hear about a psychic chihuahua?
Oh, dear. The psychic chihuahua was the one who was asked to make predictions, obviously, put your paw on this option or the other, and apparently it did very well. It's obviously in this now long line heritage that goes back, 5 years of animals predicting the future, starting with Paul the octopus, who predicted the World Cup games.
Oh, that's right, yes.
Yeah, he did very well. He actually did a pretty good... If you put your money on Paul, you would have done quite well. This 3-year-old chihuahua, whose name was Spider, God knows why, was asked to make... Well,
octopi have 8 legs and spiders have 8 legs, so why not?
But this is a chihuahua.
I know.
At 9 predictions, he got 6.5 right, which is better than most psychics, because we are doing a survey of psychics and their predictions, and the success rate is about 5%.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.